All right, welcome back to geometry. Today we're going to take a look at section 12.6. Going to continue to talk about three-dimensional measures, surface area and volume, but all we're doing today is just changing up the shape. So far we've looked at prisms, we've looked at cylinders, we've looked at pyramids, and we've looked at cones. And today we're just going to change up the shape and look at spheres. Okay, and it's kind of hard to draw a sphere, so what I've done is I've just drawn a circle and then tried to put a equator around it or a belt around it to try and make it look three-dimensional. But the value that we're going to be worrying about with all of these is we're going to need to know or understand what the radius is. So the radius is going to be defined to be, no surprise, the distance from the center of the sphere out to any point on the three-dimensional surface. Okay? Now, before I get to the theorems, I also want to remember, before I forget, that a hemisphere is defined to be half of a sphere. So a little bit different prefix when we're in three dimensions. Instead of semi, like we had with circles, now it's hemi when we're talking three-dimensional. So hemisphere is half of a sphere. Okay? Alrighty, and then the two theorems that'll get us the measures. Theorem 12.11 gives us the formula for the surface area of a sphere, which is 4 times pi times the radius squared. And theorem 12.12, which gives us the volume of a sphere, which is 4/3 times pi times r cubed. Just as you're jotting them down, make sure you get the powers correct. Surface area, the power on the r is 2. For volume, the power on the r is 3. So just make sure you get those correct. And feel free to pause the video if you need to make sure you get those down correctly in your notebook. But next, I'm just going to do a couple of examples just to get, so everybody has a couple of simple ones in their notebook. All right, here it's a little bit tough to see, so maybe I'll overdraw it in yellow. The value that we're told in the problem is the radius. So I tell you in the problem, this is a sphere that has a radius of 4. And what I'm going to ask you to do is calculate the surface area and the volume of the sphere. So our formulas, I'll just jot them down again so you have them in front of you. Surface area is 4 times pi times the radius squared. So in our problem, when the radius is 4, it'll be 4 times pi times 4 squared, which would be 64 pi as an exact value. And that'd be square centimeters, or an approximate value, 64 times pi is about 201.1. So like always, your choice whether you give me the approximate or the exact values, okay? You don't have to do both, just one or the other. And then the volume is going to be 4/3 times pi times the radius. In fact, I meant to give you the formula again. 4/3 times pi times the radius cubed. So in our problem, the radius is 4, so it'd be 4/3 times pi times 4 cubed. And what does that turn out to be there, guys? That would be, I think, 256/3 pi cubic centimeters. Or again, I'll give you the approximate as well. So let's see, 256 divided by 3 times pi. If I punched okay, I got about 268.1 cubic centimeters, if I punch that out okay. All right. Okay, one more example like that. Again, a little bit tough to see, so I'll highlight it in yellow. The measure I'm giving you this time is actually not the radius, but the diameter of the sphere. So this 14 meters is the diameter. So obviously all I'm doing is just forcing you to do that little bit of work to go from diameter to radius. So therefore the radius would be 7. And again, the two measures, surface area is going to be 4 times pi times the radius squared, which would be, 49 times 4 is 196. So this would be 196 pi square meters, which would be approximately, if you want to punch out the math with the pi, 615.8 square meters. So there's the exact and the approximate values for surface area, and then volume would be 4/3 times pi times the radius cubed. Okay? And so our volume then would be either 343/3 pi. Nope, I forgot something. Doggone it. That's wrong. Error. Let me choose my deluxe eraser. I forgot something there, guys. I punched 7 to the 3rd power, but then I forgot to multiply by 4. Sorry about that. So it'd actually be 1,372/3 pi cubic meters. Or if you'd prefer to approximate it, let's see. We get about 1,436.8 cubic meters. Okay, so your choice which way you want to leave your answers, exact or decimals. Okay, alrighty. So then what we can do also is turn the problems around, kind of do them backwards, like we've done so many of our other problems. As an example here, I ask you to find the radius of a sphere given a piece of information. And I put 2 problems on the same screen here. So as an example, if I tell you the volume of a sphere is 150 pi cubic centimeters, can you find the radius? Well, the idea is start with the formula. So the formula for the volume of a sphere is V is equal to 4/3 times pi times the radius cubed. And then what we're going to do is fill in what we know, and what we know is the volume, 150 pi. And then what we're being asked to do is solve for R. So can you guys solve that equation for R? Sure. The first thing we'd have to do is get rid of the 4/3 and the pi. And let me know if this is okay with everybody. I'm going to do that by multiplying both sides by 3/4 pi. So that the 3 would cancel top and bottom on the right, the 4 would cancel top and bottom on the right, and the pi's cancel top and bottom on the right. Another way to say that is I use the reciprocal of 4/3 pi. So what I'm left with on the right-hand side is R cubed. And then on the left-hand side, the pi's would cancel. Oop, I got a little aggressive there. There we go. That looks a bit better. The pi's cancel top and bottom. And then 3 times 150 divided by 4 is 112.5. And then to get rid of the power of 3, we have to take the cube root of both sides. And you guys might need to take a close look for your cube root key, but it's on your calculator. So when we take the cube root of 112.5, what we'd get as a result then is about 4.8. So it's not quite exact, but it's about 4.8 centimeters. Okay? Or here's another example. What if I ask you to find the radius given that the surface area is 40 pi square feet? Well, what we do is start with the formula for surface area, which is 4 times pi times radius squared. And what we do is replace surface area with what it's equal to, which is 40 pi. And then what I need you guys to do is help me solve for R, just as we did on the first example. This one's just a bit easier. To get rid of times 4 and times pi, we divide both sides by 4 pi, so that the 4's and the pi's cancel on the right-hand side. And then on the left-hand side, the pi's cancel, and 40 divided by 4 is 10. And then to get rid of the power of 2, we take the square root of both sides. And so R is going to be the square root of 10, which is about 3.2. And here we're in feet, so approximately 3.2 feet. Okay? So you'll find some of those problems in your assignment where we give you a volume answer or we give you a surface area answer, and we ask you to work backwards to the radius. Okay? Alrighty. And then just 2 other things. First, this is the tough one. We can combine some of our known shapes to form new shapes. So as an example here, what I've done is I've taken a cylinder, which we already know about, and what I've done is I've attached on top a hemisphere. So half of a sphere. Half of a sphere. Okay? And what I could ask you to do is find the surface area and volume of this kind of strange looking shape. Okay? So as an example, the surface area, and this will actually be the harder one, would be found by calculating the surface area of the cylinder, almost. We're going to have to make a little adjustment there, plus the surface area of a hemisphere. Okay? Now, the surface area of a hemisphere is going to be fairly easy. What we're going to do is we're going to take our formula for a full sphere, a complete sphere, 4 times pi times the radius squared, and we're just simply going to cut it in half. No problem. But the adjustment has to come with the cylinder. Normally, the surface area of a cylinder is 2 pi r squared plus 2 times pi times r times h. But unfortunately, we have to make a small adjustment. And let me just give everyone 5 seconds to think it over. What would the small adjustment have to be? Surface area of the hemisphere is just fine. We're just going to take the surface area of a complete sphere and divide it by 2. But we have to make a small adjustment to the cylinder. Do you guys see what it is? This part is fine. This is going to give us the lateral surface area. That means the surface area for the side. But it's the first part that we have to adjust, because 2 pi r squared usually gives us the area of the top and the bottom. And we don't need both of those because of the way the hemisphere and the cylinder come together. We don't need a top and bottom, we only need one of those. So what we have to do is adjust by removing the 2 and making it 1. But other than that, now we're just fine. Now we could replace the radius with 6 and the height with 4. Again, replacing radius with 6. So we can simply input those values and we're all set to go. What we'd have then is 36 pi plus 48 pi plus, let's see, what would that be? 36 divided by 2 is 18, so 72 pi. And so 36, 48, and 72, what does that add up to? 36 plus 48 plus 72 would be 156 pi square centimeters. And again, for those of you guys who like the approximate, I'll multiply that by pi for you. So the approximate would be about 490.1. 490.1 square centimeters. Okay. So with a little bit of adjustment, we can calculate the surface area for this strange looking shape. Now the volume is actually going to be a little bit easier. The volume of this weird looking shape is just simply going to be the volume of the cylinder down below plus the volume of the hemisphere up above. No adjustment required. We just simply find those two values individually and we're in good shape. The volume of a cylinder is pi times the radius squared times h, and the volume of a hemisphere is going to be 4/3 times pi times the radius cubed, which is the formula for the complete sphere, divided by 2. We're just going to cut it in half. Okay? And I got a little carried away. Let me fix this, guys. Let me fix this. I got a little carried away. Let me deluxe eraser one thing. Just going to deluxe eraser the radius and put it in as r to start with, because I didn't put in, let me show you. I put in r's and h's over here. I wanted to put in the r over here. Sorry about that. I got a little carried away. And now I'm going to put in all the values. Now I'll put in 6 for the radius and 4 for the height. 6 for the radius. And now we should hopefully be all set to go. Let's see if we can punch these fellas out. 36 times 4, that's 144, isn't it? Yep, so this first one would give us 144 pi. This next one, I'm going to use my calculator so I don't get that one screwed up. So 4/3 times 6 squared, and then divided by 2 would be 144 pi. So we'll end up with a total of 288 pi. Or again, for those of you guys who like the approximations, that'd be approximately 904.8, and both of those would be in cubic centimeters. Okay, so there'll be some problems in your assignment as well where you have to calculate surface areas and volumes of some strange looking shapes. Just put shapes together that you know, and maybe make some small adjustments, especially with surface area, and you should be in good shape. Okay, and finally, the last thing I just wanted to mention, it's not going to have any kind of theorem or formula, but when we create a hemisphere, we cut a circle into 2 equal parts. The hemisphere traces out on the sphere something called a great circle. And from geography class, you may have heard Mr. McDonald talk about what's called a great circle route. And this is the idea that when you have 2 places on a sphere, and Mr. McDonald would have been talking about the surface of the earth, if you have 2 locations on the surface of the earth, and you want to calculate the shortest possible trip that can be made between the 2 places, what you do is you create a great circle route. So if you have 2 places on a globe, let's say one of them is, let's see, I better go in red so you guys can read that. What if one of those places was England and the other place was what we now call America, and you wanted to figure out the shortest possible route between those 2 places? You create what's called a great circle route. And what you do is you pass a plane, a flat surface, through the earth so that the plane goes through the center. That's the important part. It has to go through the center. And it's possible to create a great circle route between any 2 locations anywhere on earth. All right? Now, it might need to be adjusted. You might need to pick this whole fella up and make rotation somehow. So you might have to move that plane so that it hits the 2 places that you're shooting for. All right, I could blow this up a little bit. All right, so it hits the 2 places that you're shooting for, but that will always give you the shortest route. So as an example for airline pilots, if airline pilots could fly the absolute shortest possible route between 2 locations, they would always be flying their jets on great circle routes. So I just wanted to mention that too, that a great circle route is just a plane that passes through the center of the earth. And if you do it so that it hits the 2 places you're concerned with, like America and England here, all right, that gives you the shortest possible route. And you'd have a hemisphere above and below that great circle route. Okay, so that's it for section 6. So go ahead and stop the video, take a little bit of a break, and then go ahead and get started on your assignment. All right?